It's really pouring it here outside in Liverpool, so if there's a lot of banging, it's the rain on the window. I apologize about that. So let's go and duplicate our red version and let's make the greenish yellowish one. Yeah, so right click, duplicate, and then say replace the red for yellow in the name. Open it up. So in the spiral ribbons, let's change the color to this color. Copy it off me. And then we don't really need the jitter position, so let's remove it. The color of the next one will be this hex. And then the color of the last one will be this hex. Cool, so you got those. And here in the rotate around point of the ribbon, I want to do some changes in order to make it appear more like the yellow effect. So the waveform will stay at sine, but the amplitude I'll put to 3.12. And the second one I'll put to 1. Find it, then open here, and then in the rainbow one, replace it for it. Hide this and show, sorry, not the rainbow one, but in the yellow one. There we go. And click away from the animation. No, click on the animation and then add it. And then if at first we are 0, we go up here and we're still 0. We go up there and we are 1. And click the bell. And click the bell over here as well. So that's our yellow one done. And now, finally, let's create the rainbow one. So navigate to this, duplicate, change the word yellow to rainbow, open it up. So let's start with initialize particle. The color needs to be this one, copy it from me. Okay. And here we're gonna do a large shift in hue. Okay, so we go from minus what is there already to 35. And the rest can stay as it is. In the next one, we go for this color. This rain outside is quite distracting, I apologize. And we go from, yeah, so you got this color, and we go from minus 0.1 to 174. And then for the final one, initialize particle, we use similar to before color. So take this color from me, this one. And the hue shift, we want to go to 3.2. While the rest stays the way it does. Perfect. Now I believe that here I click on the plus to add a jitter position. And the jitter position, I will have to 2. And here I found it a bit overpowering if there's the sprite ribbon, so I'm going to delete it. Sorry, I delete the sprite renderer, we keep only the ribbon renderer. It just works better that way for me. And that is like the difference between this one and the other colors. So we navigate to it. Here we go in and we make the rainbow one visible and we change to it. And then we bind it by clicking on the animation here and then clicking this rainbow. We click the bell. We go up here, we click the bell again. We go up to 1 here. To 0.5 and I click the bell to that and I will make it visible. There it is, really cool rainbow. And finally I'll go up there and I click the bell again. And now I click away the animation and here I make sure that all of these are set to be visible, and it makes this insane mess. And then I make sure that each outside of the animation has opacity of 0. Okay. Wonderful, and we compile and we save. And now we just need to bind them to the graph. So go into the graph. And here I'm going to do the following. Right after this, I'm going to be changing visibility. But because I'm going to be changing visibility, I also want it to happen at event construct. Okay, so what I'm going to do is I will drag each of these colors. And I'll set visibility to hidden. So that makes sure that when I click play and I'm playing like while being outside of the portal, when a level starts, these are invisible. And that's important for me. And then over here, I want to then start toggling their visibility. And there isn't a toggle, I don't think, so I made a bit of a mess, but bear with me and we'll get there. So let's start with the blue one and set visibility to visible, that's correct. And I want the following to happen, okay? So a bit of a spaghetti here, but we'll get there. So when I set the visibility of the blue one to be true, I want immediately every other one, so let's get them, red, yellow, and rainbow, the rest of them, I want to toggle to invisible. So I'm going to duplicate this and place it here and say invisible, hidden, and I connect these over here. Like so. So the logic is blue goes visible, the rest go invisible. And if I had the patience, I could turn this into a loop. So it does it with a loop instead of me doing it by hand like this. But I'm not going to do that now because I don't want to overcomplicate everything. So let's get ourselves 3 more of these. And the logic is the same. So here I'm going to set the red one to visible, which means that immediately I want the rest to be invisible. So let's add 3 of these. So I made the red visible, which means that the blue needs to be invisible, the yellow needs to be invisible, the rainbow needs to be invisible. Here I will make the yellow visible, which means that blue, red, and rainbow need to be invisible. Here I'm going to make the red one visible, which means that yellow, red, and blue need to be invisible. And I connect these to the darken. And that is like the spaghetti that could be fixed if we were to do a loop, but sorry, we're not going to do that now. So let's save and let's play. So I go through blue, and we have the blue on the screen. I go through red, and we have the red one on the screen. So we're in the other level again, just to quickly test, and we have the red triggering, and I deleted by mistake the light source here, ignore that. And then we're back. If I go through yellow, there's just the yellow stuff. If I go through this, there's a rainbow. Cool. So those are the different colors displaying, and next we want one final polish in our blueprint. That final bit of polish that I want when I go through here. See, I'm holding down the W and I just immediately go forward. Let's say that for some reason the loading moment that happens was a bit longer. I would have liked for the player to be frozen in place. Oops, that was bad. I would like the player to be frozen in place, and then I want to release them just once the screen on effect is off. So what I'm going to do is I will go back here, and right after the first time that I darken the UI over here, I'm going to create a custom event. And I'm going to call it Freeze Player. And this Freeze Player I'm going to call here. And I will color it, because colors are cool. I don't even need this. And this Freeze Player I shall place right here. I'm going to move this down. And this goes here. So you want to add this, I kind of started explaining it already, but we really want to have the freeze player in order to prevent any bugs. Because yeah, we don't want the players having fun and like something freezes when loading happens or whatever, but the character movement does not freeze, the input is not frozen, so like they end up like teleporting, but they've fallen off a cliff or something like that. We don't want things like that happening. So here I'm going to say delay, and I'll put it to be 0.3. This is just for like a sanity check to make sure that there's no issues. And I'm going to drag as BP third person character, get, and there's in there a preview thing that says character movement. There it is, get character movement. And we already have pre-built stuff called set movement mode. And here on the top I'll connect it, and I'm going to set it to just none, which essentially means that they're frozen. And then down here I will create a custom event, and I'm going to call it Unfreeze Player. By the way, you can create the freeze and unfreeze to be actual functions inside of the player blueprint, and then using this reference just call them immediately, and that would actually be tidier and better coding practice than this, but it works here for us. So just saying, giving you like that as a tip out there in order to improve on your own. So set movement mode, and let's pull that up. This goes here, and this one goes back to walking, and we set it like so, and we drag that box there. Wonderful. So now that we've frozen the player here, right at the end of everything having happened, we want to unfreeze them. We just made the unfreeze. There we go. And we want to make sure to connect the top branch to it as well, like so. And colors, we like them, so we place that there. And we compile, and we save. And now if we play, as I'm walking, now I'm frozen, and here I unfreeze. And that's just wonderful. I freeze, and I unfreeze. So that's just perfect work. That is our blueprint logic absolutely done. We polished it, we made the visuals and the darkening screen, and we are all done. The only disclaimer that I want to put here, by the way, is that when you're switching from one level to another and this screen appears, this screen now has a fixed duration that we created together with you. As such, the logic that we're executing now, it doesn't really know whether when you're loading from level A to level B, everything in level B has loaded. By everything, I mean the models and the shaders. The way the engine works is that the moment you find yourself, the player, into a newly loaded level, all of the different models on the screen will go and be requested for a draw call through the CPU. It happens instantaneous and shouldn't introduce any hiccups unless you've created a messy level with way too many draw calls, but for that, again, a topic for another time. You can read in the description, I have a link for draw calls. But let's say your draw calls are tidy up and everything is okay. you found yourself into the new level. But a mesh having loaded and the draw code being executed does not mean that the shader associated with texturing and the material graph of that model has loaded as well. Often, it will actually not have loaded. The player will be in there, and that shader, that material, will start loading in, and it will start compiling on the CPU on demand. And you can probably already guess if you have a bit of experience optimizing and game deving, but that essentially means that the moment you teleport into a new level and the moment you unfreeze, you might get a shader compilation stutter. And that is something that you would like to prevent. My logic right now for this, it does not prevent anything like that. You will need to wait for the game in the background to compile shaders while your screen is dark, and only after everything is compiled, only then you want to remove the dark screen and the vortex and unlock player movement. I don't do any of that in this tutorial series because it's actually quite a bit complicated and something out of my depth. It would be something more akin to much more knowledgeable tech artists than I am and programmers. I will leave you with this video in the description of my video where YouTuber Nan's Dev Diaries, she goes over some ideas of how to repurpose the Lyra common loading screen, which is a template created by Epic, in order to accomplish some of this shader compilation and on-screen waiting for the shaders to be compiled before like removing the loading screen. She does absolutely wonderful work in here, and it's a bit out of my depth, as I already mentioned, but hopefully it will be useful to you. And thank you very much, Nan's Dev Diaries, for creating this wonderful video. But back to our work, everything on the visuals is done. Our blueprint logic is executing flawlessly as well. There's only one truly final video that I would like to create in this series, and it deals with this. Not too sure if you can hear it because it's raining outside and my microphone is not nearly as good, but I hope you hear that. When I'm in proximity of the portal, an eerie sound plays, and I think that's just a nice polish that makes the portal feel even more real. And then as you go through, there's also a sound, a whoosh playing, kind of indicating to you that you went through the portal. So in the next video, final video in this very long series, let's create the audio. See you next time. And I want the following to happen, okay? So a bit of a spaghetti here, but we'll get there. So when I set the visibility